Hello and welcome to Chapter 10, Section 7. Today we're talking about independent and dependent events. An independent event is if the result of one event does not change because of another event. For example, if I were to flip a coin and then I were to flip that coin again, it doesn't matter what I got the first time. The second time is going to be independent of it. If I pull a green marble out of a bag full of colored marbles and then I put that green marble back in and I pull out another marble, it doesn't matter what I did the first time. The results are going to be what the results are going to be for that second time. A dependent event is if the results of one event change the probability for the next event. That means if I pull a green marble out of a bag full of colored marbles and I keep it, and then I pull a second marble out, what's the probability that that's going to be green? If I keep that first marble, the chances for that second event are different, and that second event is dependent on what happens in the first event. So, first thing we're going to ask you to do is classify a bunch of situations as dependent or independent. So, if a dime lands heads up and a nickel lands heads up, is that nickel dependent on what happens with the dime? No, those are going to be independent, in-depth. You choose a colored game piece and then your sister does. Does what your sister chooses depend on what you choose? Yes, it does, because if you picked the blue one, she doesn't get to pick the blue one. The blue one's not there anymore. So that is a dependent event. A number cube is rolled 2 times. Those are independent events. Doesn't matter what you rolled the first time, because the second time can still be whatever it wants to be. One student is chosen to be line leader in a class, and then one student is chosen for the caboose. That's a dependent event, because I can't choose the same person to be line leader and caboose. Once I choose that first person, then they're out of the running, and I have fewer students to choose from for caboose. Make sense? Now, how do we write this mathematically? If A and B are independent, then the probability of A and B, so I pull a green marble and I put it back and then I pull another green marble, that's going to equal the probability of A multiplied by the probability of B. So let's try this. We're going to randomly select a marble, we're going to replace it, and then we're going to randomly select again. We've got 7 blue marbles and 3 yellow marbles in a bag of marbles. What is the probability of me pulling a yellow first, putting it back, and then pulling a blue? Well, the probability of me pulling a yellow first is going to be 3 out of a total of 10. And the probability of me pulling a blue when I put that yellow back is going to be 7 out of 10. So I get to multiply these together. The probability of me pulling a yellow and then a blue is going to be the probability of one times the other, which is going to be 21 out of 100, which is a 21% probability. What is the probability that I pull a yellow and a yellow? So if I have the probability of a yellow being 3 out of 10, and then and I put it back, and another yellow is also 3 out of 10, multiply, I'm going to end up with 9 out of 100, or 9%. 9% of the time. I have a 9% probability of pulling a yellow, putting it back, and then pulling another yellow. What is the probability when I roll 2 number cubes that I'm going to get doubles, and then I'm going to get doubles, and then I'm going to get doubles. So I'm rolling 2 dice 3 times. So what we need to understand here is our sample set. So I could roll a 1-1, a 1-2. Let's make those numbers. A 1-3, a 1-4, a 1-5, a 1-6. I could roll a 2-1, a 2-2, a 2-3, a 2-4, a 2-5, a 2-6. A 3-1, a 3-2, a 3-3. And we know how it goes. Now, if this continues, assuming this is a red dice and this is a blue dice, so for some people it's going to matter which one I roll first and which one I roll second. How many possible outcomes are there? There are 6 outcomes on the first one and 6 outcomes on the second one. So I have a total number of 36 outcomes. And the probability that I'm going to roll a doubles is going to be rolling double 1s or double 2s or double 3s or 4 or 5 or 6. So that is 6 possibilities of doubles out of 36 rolls. Now I'm going to reduce that. I'm going to divide the top and the bottom by 6, and I'm going to say that that is a 1 in 6 probability that I'm going to roll a double. Now, what's the probability that I roll a double the second time? Well, it doesn't matter what I did the first time because it's an independent event. So I'm going to multiply it by 1/6, and then for the third time I'm going to multiply it by 1/6. And I'm going to get out my calculator, and I'm going to see that that is a 1 in 216 chance. That gives me 0.004629. That is a 4.6% chance that nope, look at that. It is a 0.46, so it's a 0.5%. It's a 0.5% chance that I roll doubles. Try check it out number 2. Pause here. Come back when you're done. Check it out number 2 asks what the probability of spinning the spinner on an odd number and then spinning the spinner on an odd number are. Now these are independent events. So spinning odd is going to be 1 out of 2. It's actually 3 out of 6, and we reduced. Times 1 out of 2 is 1 out of 4, and that's going to give us a 25% chance of spinning odd than odd. What happens if A and B are dependent events? Well, that math looks like this. The probability of A multiplied by the probability of B after A. So we have to take that into account. I've got one bag of marbles. It's got 3 red marbles and 2 blue marbles. What is the probability that I pull a red and I keep it, and then I pull a blue? So the probability that I start by pulling a red is going to be 3 out of a total of 5. And then the probability that I pull a blue is 2 blues out of one of these is gone. So now I only have 4 marbles in that bag. So 3 over 5 times 2 over 4 is going to give me 6 over 20, which is 3 over 10, which is 30%. I have a 30% probability of pulling a red, keeping it, and then pulling a blue. Let's try one more of these together. Let's say I've got 7 pink flowers and 5 yellow flowers. What is the probability that I will pull a pink flower and then a yellow flower, but keep them both? So I am going to find the probability of pink. Probability of pink is going to be 7 over 12, and the probability of yellow is going to be 5 over, and there are now only 11 left. There are still 5 yellows left because the first time I pulled a pink one. So I'm always going to go with that number, but my total is going to go down. So times 5 out of 11, and I end up with 35 out of 132. 132. This is 11 times 12. This is 7 times 5. They don't have any factors in common. So I'm going to go straight to dividing, and I end up with 26.5%. Pause here and try and check it out, number 3, and come back when you're done. So that said that we had a bag with 10 red marbles, 12 white marbles, and 8 blue marbles. What's the probability of pulling blue, then red without replacement? Well, that's going to be 8 over 30, which is really 4 over 15, times 10 over 29. And when I cancel and multiply straight across, I get 8 over 87, which is 9.2%. Your homework tonight starts on page 755. You're going to do numbers 17 through 27 odd. Please make sure you ask if you have any questions, and I will see you later.